All right, so I am in the identifying properties of quadratics, quadratic functions workspace. And here you are just sort of going through and going more into detail about general form, factored form, and vertex form. So the first thing they're having you do is identify the different forms that you can see a quadratic in. So remember that general form we also called standard form. Looks like this, our ax squared plus bx plus c. The factored form looks like this here. And then our vertex form looks like this here. And you can read over here on the left-hand side and see what the information they give you about all three forms. So now as you go through on the right-hand side here, it's going to give you a quadratic function in a certain form. And so which one does this match up with? Well, that one's going to be our vertex form, right? Because we have that quantity, that x minus or x plus something quantity squared. Okay, and then we have that k on the end and the a in front right here. So I'm going to identify that as vertex form. This is factored form, so it's always going to be an x plus something, x minus something, or vice versa, or both. This is, again, vertex form. This should be pretty simple for you to go through. Now we have our ax squared plus bx plus c. That's our general or standard form. And then we have another general form here. All right, so I'm going to click on done. Let's move on to the next section. All right, so here, now they're diving into, well, what can you tell from each form? So in general form, we know that we can easily see the x or the y-intercept, right? That's our c value. It's 0, c. Okay. In factored form, we can very clearly see our x-intercepts. So this R1 and this R2, those are our x-intercepts. So where that parabola crosses the x-axis. Let me show you down here. So x-intercepts right there. Our y-intercept where we cross the y-axis. And then in the vertex form, we can see obviously our vertex. So that's our h comma k. So here in this example, it says +1 minus 9. So remember, that's always the opposite there. So our vertex is going to be at -1, -9. And there it is down there. So if we go through and we identify, well, what characteristic would be visible from this? This is vertex form. So we know we would be able to see our vertex. In general or standard form, remember, we're able to see our y-intercept. In our factored form, we can see our x-intercepts. So now it wants to know which of these functions has a vertex of 6, 3. So now we're looking through 4 possible equations in vertex form. So remember that 6 is going to be the opposite, and that 3 will be positive. So that's going to be our function there. So it's going to be x minus 6. So our h is 6, and then our k is 3. And this is also, remember, when we looked at the transformations, we'd be moving right 6, so +6, and then up 3, +3. All right, which of these functions has x-intercepts -2 and 3? When we're written in factored form, our x-intercepts are going to be actually the opposites. So if one of the factors is x plus 4 over here, we know that the x-intercept is going to be -4. And if the other factor is x minus 2, the x-intercept is going to be +2. So we're just going to have the opposites of those. So I have -2 will be x plus 2, so one of these. And then if I have 3, 0, it's going to be x minus 3. So do that. And the way that you know if you're doing this right or not is if I were to take this -2 and substitute it for x, -2 plus 2 is 0. And the same thing with the 3. If I put the 3 in for the x, 3 minus 3 is 0. So you're looking to make these quantities 0, right? Because when we cross the x-axis, we actually are talking about the values of x when y is 0. Right? And then lastly, which one of these functions has a y-intercept of 0, -6, and that's just going to be our c value of -6. All right, so this next section, we're determining the vertex and the axis of symmetry. So remember, the vertex is that maximum or minimum point, and the axis of symmetry is that vertical line that runs right through it. It cuts that parabola perfectly in half. So again, you have a lot of information over here. Let's just look at what we're filling in our chart here. So the vertex in vertex form is going to come right from my HK here. So I have an x minus 4 is going to be +4, and then +9, that'll be a +9 there. And then my axis of symmetry is going to be the x value of that vertex, x equals 4. So I'm going to go through and do that for the vertex form equations. So here, I know that that's going to be -3, -8. And therefore, my axis of symmetry is x equals -3. All right, and that is all of my vertex forms. So now let's look at our factored form. So over here on the left-hand side, they tell you that you can find the vertex from the factored form by adding your two r values and dividing by 2. So we're trying to find the midpoint of those. So just keep in mind that when you have, say, a quantity x plus 3, your r value is actually going to be -3. It's going to be the opposite. So in this example here, you're asking yourself, well, what -3 is 0? That's going to be 3. So the r value here is going to be 3. The r value here is going to be 7. So if I add 3 and 7 and divide by 2, we have 10 divided by 2 is 5. So we know that 5 is going to be my x coordinate. Now to find the y coordinate, all I need to do is I need to substitute that value I just got in for x. So I'm going to put 5 in this equation. So if I plug in 5 here, 5 minus 3 is 2. 5 here, 5 minus 7 is -2. And this is just a product. We're multiplying. So 2 times -2 is -4. And that's my y value. Remember, my x is just going to be that x value. So I'll do the same thing here. So I will add -12 and +18 to get 6. Divide that by 2. That's 3. And then when I substitute 3 in, I have 15. And 3 minus 18 is -15. So 15 times -15 is -225. And my axis of symmetry is 3. All right, and so lastly, we have our general form or standard form. And the way that we find our vertex here is with this equation, x equals -b over 2a. And remember, b is going to be the coefficient of the x term, and a is the leading coefficient of the x squared term. So if I take my b value here, which is 4, I'm going to take the opposite of 4. That's where that negative comes in. So I have -4 divided by 2 times the coefficient of x squared, which in this case, if there's nothing there, is just 1. So -4 divided by 2 times 1 or 2 is -2. And that's going to be my x value. And now I'm going to substitute that in for x to find my y value. So if I put -2 in for x squared, I get -2 times -2 is 4. 4 plus 4 times -2, so that's going to be -8. So 4 minus 8 is -4. And then I want to subtract 12 more is -16. There we go. And my axis of symmetry, again, is just the first coordinate, that x. All right, and I'm going to do with this last one here. Now, if you notice, if there is no b term, so there's no x term, linear term in here, your vertex is actually just going to be the y-intercept, which is going to be right at that 16 there. So 0, comma, keep hitting that too, 16. All right, and then our x, our axis of symmetry, is going to be there, 0 there. So if you ever see any standard form or general form where there's no x term, you know your vertex is just going to be right at that, that y-intercept, because all this is doing is moving up 16. It's not moving left or right. All right, so we got 2 more questions in this workspace. So here, we're now trying to determine another point on the parabola. And remember, parabolas are symmetric. So this point is going to be directly across that axis of symmetry. So here in my example, I have a parabola has an axis of symmetry of 1 and a point -3, 2. What point lies on the parabola and is symmetric to the given point? So if my axis of symmetry is 1, how far is -3 from 1? Well, if you think about a number line, -3 from 0 is 3 units far. So if we go 1 more to 1, it's 4 units. So what I'm going to do is I need to go now 4 units on the other side of 1, continue 4 units past 1. And so that's going to be at 5. And we're not going up or down, so we're still going to stay at 2. All right, the next one, a parabola has an axis of symmetry of -4 and a point 0.06. So -4 is 4 units from 0. So let's go 4 units on the other side of 0, which would be at 4, which doesn't give me an option here. Oh, I apologize. So we're actually going the other way. So if my axis of symmetry is -4 and I'm at 0, I'm 4 units from 0, I need to go 4 units past -4. So that brings me to actually -8. And again, we are not going up or down, so we're staying right at 6. All right, next, a parabola has a vertex of -1,6 and a point 2,3. I want to find another point. Don't be thrown off by this. Your axis of symmetry, which we used in the last 2, is still just -1 here. So if my point is at 2, 2 is on the right side of -1 and it's 3 units away. So I'm going to go 3 units away on the left side of -1, which brings me to -4. And I'm still at 3. All right, a parabola has an axis of symmetry of 5, x equals 5 and a point 3, -1. So I am 2 units away from 5 on the left-hand side of it. So I need to go 2 units on the right-hand side of 5, which will bring me to 7. So here, I'm not actually given any multiple choice options. I need to type that in. And my y value will still be -1 there. Okay, and then lastly, same thing, my axis of symmetry is going to be right here, this 3. And my point is 4, 1. So I am over 1 to the right of 3. So let's just go over 1 to the left of 3. And that brings me right to 2, 1. All right, and then on to the last part of this workspace. So the last thing here is we are just trying to decide whether a parabola is concave up or concave down, and we can determine that by the sign of the A value. That A value is going to tell me, right, if it's positive, we're going to open upward, like this green one, and if it's negative, we're going to open downward, like this blue one. Okay, so we can see this very easily in standard form. So right here, that be careful because this is not in general or standard form, right? To be in the correct order, I need to have the highest power go first. So the leading coefficient here is actually that 1, a positive 1 on the x squared. So that is a positive leading coefficient, so we are going to be concave up there. Here's another general form. This is in standard form, and my leading coefficient is -3. So my leading coefficient's negative, that's going to be concave down. So now we have, let's look at vertex form. Vertex form, here I have an A value of -5. That's going to be concave down. Here I have an A value of 4, concave up. And here I have, there's no A value there, so my A value is actually 1, and that's a positive 1. So that's concave up. So then lastly, I'm left with 3 equations in factored form. But you can nicely see the A value right here, that's negative, so that's going to be concave down. This one's also negative, concave down. Oh, moving a little fast there. This one's actually not going to be negative, and hopefully you see that mistake I made right there, because we have that extra negative inside. So you know what a negative times a negative is, becomes a positive there. And then lastly, we have positive, positive, so that's also concave up. All right, so hopefully you can use this video to help you complete this workspace.